Yes, of course, no problem. All right, we're gonna talk here next about rational functions. So I think that the sequence that I had listed on the syllabus, I'm going to violate a little bit in terms of the topics that we're going to cover here. Mostly because being able to factor quadratics and polynomials is still kind of a really important skill inside of this chapter, and there's really nothing in this chapter that we're doing that required anything else. So it felt to me like it'd be nice to group this together so that it was still kind of, well, while different, we're still using some of the same factoring skills that we've been working on, so those should still be relatively fresh in our mind. Does that make sense to you guys? So again, factoring quadratics in particular, but to some extent some polynomials even, not having to do synthetic division, but doing some of the other factoring polynomials problems that we did inside of chapter 5 would still be applicable, like the sum and difference of two cubes might pop up here or there, things like that. Okay? Okay, so let's define what we mean by a rational function. I'll just say. Okay, so the simple way of saying what a rational function is it's just a polynomial divided by another polynomial. That's the simplest way of kind of thinking about it. Now we want to be a little bit careful there, because when we talk about a polynomial, we know that like things like 7 is still a polynomial. Like it's not a very interesting one, but it still counts. So when we say a rational function, we say polynomial divided by another polynomial. The numerator of that rational function can be anything other than 0, because anything divided by 0 is just 0. We don't want to count that as a rational function. Everybody's okay with that? And the denominator needs to be a non-constant polynomial. So the denominator, as long as there's an x in there, that's great. Right? Because we don't want something like x over 2 to be a polynomial, or to be a rational function, because x over 2 is just really the same thing as 1/2 x, which is linear. That's just a polynomial. So these little qualifiers here are just tacked on to make sure that we're not including like polynomials or constant functions that we've already talked about. Okay with that idea? So just to look at an example of things that are rational functions. So something like f of x equals x plus 3 over x plus 2. That's a rational function, right? The numerator is a polynomial, the denominator is a polynomial. So when we talk about rational functions, we'll talk about things that maybe look like this. Everybody's okay with that idea? Okay. So just to give us an outline of what we're going to do here, so today we're going to talk about simplifying and then multiplication and division of rational expressions. Next time we're going to do addition and subtraction. After break, we'll do a day with solving and then a day with graphing what I'm going to call simple rational functions. And that's going to be it for this chapter. So we have basically 4 lectures for this chapter. That's all the content that you're going to see in this chapter. Obviously, we'll take some more time than just 4 class days to do this. We'll probably have a day of review, and like a day when we come back from break, we'll probably give you some problems to work on for at least part of the day and just, try to stretch that out a little bit. But I really have 4 lectures in mind to get us in and out of this chapter. So it's going to be considerably quicker than the previous chapter, which is, I think, the longest chapter we look at in either semester by far. There's just a lot of skills and a lot of pieces going on inside of that chapter 5. Is everybody okay with that as a general outline? And again, when we talk about, in first semester, we talked about, in general, there's kind of 3 skills that we look at: simplifying, solving, and graphing inside of any of these chapters. And we'll spend time in each of these chapters working on those skills, plus maybe some more things, but certainly those 4. So that's just our little outline of kind of where we're going to be going inside of this chapter. So today we're going to start with simplifying rational expressions. So just a quick little vocab piece. When we talk about an expression versus a function, so something like f of x equals x plus 2 over x plus 5 is a function. If I just write x plus 2 over x plus 3, that's an expression. So there's really not a lot of, like, from what you're seeing on your sheet of paper, a lot of difference between the two. But I just want to make sure that I'm being, just being clear, try to be clear with the vocab. Everybody's okay with that idea? So a function is in 2 variables. You have an f of x and an x. An expression, there's no equal sign. It just x's or whatever. Okay. All right. So the idea here is just like reducing fractions. So when we talk about simplifying a rational expression, really it's going to be kind of the same idea as reducing a fraction. So let's just go back and review that process. So if I give you something like 2/4, what does that reduce to? 1/2, right? And most of us can do something like that in our heads. What is it that we're actually doing in our head there, though? Okay, one way of thinking about it is you can think about dividing the numerator and denominator by 2, since 2 divides both 2 and 4. Now, if we start thinking about this as a rational expression, what we're going to have to do then is start dividing polynomials by things. Is polynomial division an easy process? Not really, right? So there's another way for us to kind of think about reducing. Another way to think about it is if I do like a prime factorization, right? So 2 is prime already, but 4 I can write as 2 times 2. And then I can reduce to get to 1/2 that way, right? Do you guys remember kind of learning about reducing fractions that way? That's the way that's going to be more useful to us when we start talking about rational expressions. Because in general, factoring these polynomials is going to be easier than trying to divide them, in particular because we won't have any good idea of what the divisor could possibly be. Right? It's not very easy to look at a polynomial and go, oh, I can divide this by x plus 7, right? Like that's not likely that you're able to do that. If we were, chapter 5 would have been much easier, right? If you automatically knew what the divisors for a polynomial were going to be just by looking at it, you wouldn't have to go through all the rigmarole we did in chapter 5. So let's look at an example here with polynomials here. Okay. So here's 2 polynomials. One divided by the other. And we're going to want to reduce these polynomials. So let's talk first briefly about things that you can't do. Is it okay to do that? Look, I have an x squared on the top and x squared on the bottom. Can I just cross them out like that? Absolutely not. Very good. Why not? How is crossing those x squareds off different than when I cross these 2's off over here? Becker? Excellent. Yes, because in the polynomial case, we have addition symbols in between the terms rather than multiplication symbols. If you have everything being multiplied, you can cross things out. If you have pieces being added or subtracted, you cannot cross out addition and subtraction pieces. Everybody's okay with that idea? Okay. So that is the biggest stumbling block for stuck in the I'm going to cross and subtracted chapter 4 is you can't get that through your head that is never going to be okay to do. So instead what we want to do is we want to turn this addition and subtraction problem into a multiplication problem. And we do that by factoring. So I notice that in this case, the numerator and the denominator, each of them are quadratic polynomials, right? These are things that we would have factored in chapter 4 in first semester. This is something we should be pretty good at by now, as we should have had a lot of practice doing this over the course of the last 2 chapters. Since each of their leading coefficients are 1, we can really just do the factoring shortcut and look for 2 numbers that multiply to give us 2 and add to give us 3. What are those 2 numbers? 1 and 2. Factor as x plus 1 times x plus 2. We can do the same thing in the denominator. How does the denominator factor? 1 and 3. Very good. So x plus 1 times x plus 3. Does everybody remember how to do that factoring shortcut that we're using right here? If we need to walk through that again, let me know. It's okay to do that. But this is something that you're going to be using frequently throughout this chapter. And if you don't remember how to do that, that's going to be a problem. So if you don't and you want to, if you need to walk through it again, let's do that now before it becomes a big problem. Okay. So everybody, yeah. Oh, you're stretching. Okay. So we factored this now, right? This is not really a multiplication problem. In the numerator, I have two things that are being multiplied together. One thing, two thing. And in the denominator, I have two things being multiplied together. One thing, two thing. Everybody agree with that? Does it matter that there's addition and subtraction going on inside the parentheses? No. As long as all the parentheses are being multiplied together to that, like that, I can think about them as discrete objects, right? That each parenthesis is like its own little thing. Everybody okay with that? So, if you look at the numerator and denominator, do you see anything in common? Is there a parenthesis in the numerator and denominator that is identical? The x plus 1s. So what can we do with those? We can cross them out. When we cross them out, they really become 1s. But that doesn't really matter to us because 1 times anything is still itself. So what we're left with is just x plus 2 times x plus 3. Or I'm sorry, over x plus 3, not times. And that's our final answer. We can't reduce anything more because everything else is just being added and subtracted, right? There's no more multiplication. Does that feel okay? Let's do another example or two. But this should feel... I always thought that this was a topic that was satisfying because I liked to cross things off and make things nicer. It was one of those where you start with something that looks really terrible and you might end with everything crossed out and it's a really kind of a nice feeling. No? Maybe you'll get in. Maybe it'll be exciting too later. Okay. So here's another example. We have 4x squared minus 8x divided by 2x squared minus 8. So if we want to factor the numerator, what can we do there? This quadratic's a little bit different because it's not a trinomial, right? It's only got two terms. Does anybody notice anything about 4x squared minus 8x? Remember the first thing in the factoring tree, what do we look for? A greatest common factor. Do you see a greatest common factor in the numerator? 4x, right? Everybody agree with that? So when I take the 4x out, I'm left with x minus 2. Is that okay with everybody? Again, if I do anything you're not sure about, or you don't understand the reason why I'm doing things, please stop and ask. Walter?
So, did you just divide that?
Yeah, so the idea here is we're like undoing, if I distributed the 4x back through, I'd be back to this again, right? So we're like taking that out, so we're dividing each piece by 4x. So like 4x squared divided by 4x, the 4's cancel, and one of the x's cancel, and we're left with just 1x. And 8x divided by 4x, the 8 turns in, 8 divided by 4 is 2, and x divided by x just is 1, so you're left with the 2x, or x minus 2. Does that feel okay? Stefan? Absolutely. Let's look at the denominator. What's going on there? What's the first thing you should check for? Greatest common factor. Do you see one? 2. Okay. When I factor that 2 out, what's left? X squared minus 4. Can we do anything more with either of the pieces that are in the parentheses now that we've taken greatest common factors out? The x minus 2, can I do anything more with that? No. That's linear. That's as good as you're going to do. The x squared minus 4, can we do anything more with that? Yes. You guys should recognize that. That's a difference of 2 squares. How does x squared minus 4 factor? Anybody? X squared minus 4? Becker? Very good. And now that we have everything factored down as far as we can go, now we start looking to reduce. So what's something that we can reduce? So we're looking for things that we can cross out now. Yes. Very good. So Grace says that x minus 2's are the same. Let's get rid of those. Is there anything else? There is. Look at the greatest common factors that are in front. There's something you can reduce from those. What can we reduce from the greatest common factors? I can reduce the 2 and the 4. Everybody's okay with why it's okay to reduce that? Even though it's a single individual number and not a parenthesis? The 4, the x, and the 2 are just being multiplied to the other parentheses. There's no addition and subtraction going on, so it is okay to reduce those. Oops. So again, when we cross those out, they all become 1s. So what are we left with in the numerator? 2x, and in the denominator, x plus 2. So far, so good? Let me know if there's questions or if you're unclear on something or if you just need me to slow down for a minute while you process. That's okay. Again, these beginning skills are super important kind of moving forward and getting comfortable with the material. So I'm happy to slow down or re-explain something or just take a pause and let you process. That's all okay. Okay. We'll do one more before we turn around and start talking about multiplication. Everybody good with that plan? Seems like we're doing okay with this idea. And multiplication isn't too much more complicated than this, so that's good. All right. What do you guys want to start with here? I would start by checking for greatest common factors. Exactly. Very good. In the numerator, do we see one?
Yes.
Good. What do you see? 2. Very good. In the denominator, do you see one? Yes, an x. Very good. So far, so good. All right. Let's look at now the pieces that are left over. X cubed minus 8. Can we factor that anymore? You better say yes. I think this happened on the test, right? This is a difference of 2 cubes. So remember the difference of 2 cubes factoring pattern. We'll write that down again. So in this case, our value for A is x, and our value for B is 2, right? Everybody kind of remember doing this? I think we've done this particular difference of cubes factoring several times between the homeworks and everything else. Did I go too fast through that? Are we okay? Please stop me and let me know if it doesn't make sense or doesn't click what I did there. All right, let's look at the denominator. X squared plus 2x plus 4. Does that factor anymore? Multiplies to 4 and adds to give us 2. Are there 2 numbers that do that? I should say, are there 2 integers that do that? There's always 2 numbers that do that. But we only care if they're integers. If they're crazy decimals or like imaginary or something, we don't care. There's not, right? The numbers that multiply to give us 4 are 1 and 4 and 2 and 2. None of those are adding up to give us positive 2, right? Everybody agree? So nothing we can do with that, nothing more to do with that denominator. Okay, so let's reduce now. Is there anything we can reduce? Yes, Grace. Very good. So that's all we have left. What do you guys think about this particular topic? Not so bad? Again, if you're good with your factoring skills, this should be relatively easy, right? The harder part is probably getting the factoring done correctly. But if you're able to factor it correctly, making sure you're crossing off the right pieces is pretty easy. Everybody cool? Okay. So let's talk now about multiplication. And this is going to be the same idea as multiplying two fractions. Grace? Of course. Okay, so do you guys remember how to multiply two fractions? Let's say we have something like 2/5 times 15/4. Do you guys remember how we multiply two fractions together? Anybody with any vague recollections of this? You would have done it a lot in middle school and upper elementary school. Multiplying two fractions is a common skill there. Okay, so cross multiply is a solving technique you use to solve a proportion. A proportion is when you have two fractions that are equal to each other. It's not a technique for multiplication, though. It's a solving technique. So that is something, and it does have to do with fractions, but it's not what we're looking for here. You just go straight across, right? So 2 times 15, and then 5 times 4. Everybody's okay there? What do you still have to do, though, here? Oh, yeah, thank you. What do we still need to do here, though? Reduce, yes, exactly. So in this case, what would this reduce down to? Three over 2. Again, that should be fairly easy to see in your head that we're just dividing each by 10, right? Everybody kind of remember doing this at some point? Now, what's the problem if we try to take this same method with polynomials? What's going to get us into, what's going to make this a little or considerably harder if I have rational expression times rational expression? If I multiply two polynomials together, is that easy to do? No, that's pretty time consuming, isn't it? Because you have to do some big crazy FOIL or draw the grid or something to get that multiplication to work out. You guys remember doing that? So I would prefer to avoid that, wouldn't you guys? The way to avoid that is going to be reducing before we multiply. So if we have this same problem, what we're going to want to do is factor everything that we can. So 15 is 3 times 5, and 2 is 4 is 2 times 2. And then reduce before we multiply. So really just left with 3 times 1 times 1, or 3, over 1 times 1 times 2, which is just 2. And that is going to be a heck of a lot easier to deal with a polynomial situation than what we described previously, right? everybody okay with that idea? So the trick here is going to be to factor first, do all the reducing we can, and then we can multiply things together. And it'll always be a considerably easier process than multiplying and then trying to reduce. Good with that plan? Okay. Again, I'm trying my hardest to connect this back to something that we should be relatively comfortable with. All right. So let's say we have x squared minus 9 over x squared minus 8x plus 15 times x squared minus 25 over x squared plus 8x plus 15. First step will be to factor everything that we can. Okay with that plan? So let's start with the numerators. X squared minus 9. Is that factorable? Definitely. How does x squared minus 9 factor? You guys should be spitting these out before I can even finish saying it. Very good. X plus 3, x minus 3. Thank you. And then x squared minus 25. What does that one factor to? X plus 5. And then x minus 5. And then the denominators, x squared minus 8x plus 15. How does that factor? Multiplies to give us positive 15. Adds to give us negative 8. Becker? Very good. Negative 3 and negative 5. And then x squared plus 8x plus 15. If you could do the previous one, this one should be easy. Positive 3 and positive 5. Yeah, very good. Okay. Now that we have everything factored, let's look for things to reduce. Anybody see anything that can reduce? Okay, x minus 3s can reduce. What else? Grace? X plus 5, you said? Yeah. Okay, yep. Anything else? X minus 5, okay. Anything else? X plus 3s. So what are we left with then? In the numerator, we have 1 times 1 times 1 times 1, just 1. In the denominator, we have 1 times 1 times 1 times 1, or 1. And 1 over 1 is just 1. Everybody okay there? Now, is this problem substantially different than reducing? No, in fact, it's the exact same problem. There's just more stuff to factor and more stuff that you could potentially reduce, but it's no different, right? In fact, in our first step after we factored, we wrote it as just one big fraction, did we not? So do we need to jump into this, or does this feel like it's just kind of the same thing as reducing? Should feel the same thing, right? We can do more if you would like to. You tell me. I mean, I know how to do it, right? If you guys need to see more, we can do more if you think you got it. That's okay. I just don't want to bore you guys too much to tears today. Okay, we'll go on to division then. You guys can always come back and we can do some more at the end if you decide you want to. Back in my elementary, the rhyme that my teacher told me to remember how to do this, she said, dividing fractions is easy as pie, flip the right and multiply. So the idea here is, let's say that we have (10 over 21) divided by 35, or I'm sorry, 25 over 35. The first step is to turn it into a multiplication problem by making the reciprocal of the divisor. So notice that I had 10 over 21 divided by 25 over 35 becomes 10 over 21 times 35 over 25. And now it's just like the previous problem, right? So we'll write this in a factored form. And then we'll reduce. And our answer here would be 2/3, right? So is this going to be substantially different than multiplication? Nope, we have one additional step where we have to flip the fraction, but like, that's not that big of a deal. We can handle that. Let's do an example. Oops. Oops. That was. Okay. So, what do you guys want to do here first? Okay, let's take care of the division. So stay the same on the first fraction. The second fraction gets flipped and we turn the problem into a multiplication problem. Everybody good there? Then what? Start factoring, right? Okay, let's start in the numerators. 2x squared minus 4x. How does that factor? You just take out a 2x, right? Three x squared plus 9. How does that factor? Take out a 3x, right? X squared plus 6x plus 9. How does that factor? Again, you guys should be blasting these off at me almost before I can finish them. Remember all those factoring practices we did in first semester? Maybe some of you don't because you didn't have me first semester, but we did so much practice.
3 and 3.
It is 3 and 3. So x times x plus 3. And then 4x squared minus 8x. How does that factor? Take out a 4x, right? All right. To reduce, what do you guys see that can reduce? Okay, so I can only reduce one of them because I only have one in the numerator, but that's okay, absolutely. What else? X minus 2 is good. Anything else? Well, I can do the 2 and the 4, right? And then I can do an x with an x. Everybody's okay with that? So what are we left with in the numerator? Well, just 3. And in the denominator, we have 2 times x plus 3. What do you guys think? Again, really, is this any more difficult than division? You have that one additional step in the beginning to turn it into a multiplication problem, and then it's just like multiplication. And the multiplication was just like reducing. So really, all of these problems should feel very similar, right? They get a little bit longer because there's a little bit more reducing to do in each step, but it's basically just reducing problems. Is really what it boils down to. How do you guys feel? Does this feel pretty manageable? Good. Well, let's stop here. I think that's